Hello people, so today we will be solving LeetCode daily question, that is 641, design circular queue, and in this we have to design our implementation of the circular double-ended queue DQ basically. And for to implement the DQ class, we need to initialize the DQ with the maximum of size k. Insert friend will return true if we can insert at the front of the DQ, otherwise false. Insert last similarly, delete from front and delete from last as the pretty explanatory. Get friend and get will return the first item and the last item respectively as per the function call, and is empty and is full is, I guess, self-explanatory. Still I'll explain. Okay, so insert front adds an item at the front if possible, then return true, otherwise false. Insert last will insert the item at the rear of the DQ if possible, then return true, otherwise return false. Delete front will delete the item from front if possible, return true, otherwise false. And delete last will remove the item from the last and then return true if possible or false otherwise. Get friend will return -1 if the DQ is empty. Get rear will return -1 if the DQ is empty, otherwise they'll return the respective items. Is empty will return that if the DQ is empty, and is full will return if the DQ is full. Okay, so we need to initialize this, write this proper class, and for this we'll be using an array of size maximum size k. Let's do it just k plus 1, so just because of one based indexing. And then let's have a pointer, which are front, back, and size and q are basically the size. Okay, so let's have a int dq, and also have pointers that are front, which is equal to 1 currently, back, that is equal to, or let's just make it start from, okay, let's just start from 1 only. Back is also equal to 1 initially, then size is equal to 0, and capacity, or let's call it k, is equal to, we need to initialize the k, so let's have it capacity is equal to, uh, I'll be going with k instead. Okay, so now let's initialize the dq array of size k plus 1, and then let's initialize that this dot k is equal to k. Okay, so that's the maximum capacity, and let's fill the array dq with -1 initially. Arrays dot fill, fill dq comma -1. Okay, now firstly let's write the function that is insert at front. Firstly, if it is full, it's not possible for us to insert, so we'll just check over here and then return false. Then we'll be checking that if my current pointer is at first place, so if front is equal to 1, basically we need to go back, so front will be equal to k, yeah, just k. Okay, else we'll be having to check, oh, else I'll be decrementing the front. Okay, and then what I'll be doing is I'll be updating my front, oh sorry, yeah, okay, fine, then I'll be updating my dq of front equal to, yeah, I hope this should work. Okay, front, that will be equal to the given value. I'll be incrementing my size, and I'll be returning true in this case. Okay, insert last, it's gonna be somewhere there, the similar only. Okay, so if is full, again we have to return false in this case. Okay, then I'll be taking that if back pointer is pointing towards k, I'll be initializing back equal to 1 again, else I'll be having to increment back pointer, and then I'll be update, oh sorry, firstly I need to update the value where my pointer was currently, so dq of back, that will be equal to value. Okay, now I'll be incrementing the size again, and at the end return true. Then delete front. So if it is empty, then I cannot. If is empty, then return false. It's just a implementation heavy. Then what I'll be doing is I'll be updating the deque of front equal to -1. Okay, and then I'll be checking that if front is equal to k, I'll be updating my front equal to 1. Else I'll be incrementing my front pointer. Okay, and decrementing the size. Return true. If is empty, then delete last function. If it is empty, return false. It's not possible. Then similarly, that if my back pointer is pointing towards 1, I'll be making my back pointer points towards k, and then else I'll be decrementing it back minus minus. I'll be updating the deque of back equal to -1, size decrement, and then return true. Next is get front and then get last. Okay, if it is empty, not possible again. If is empty, return -1, else return deque of front. Similarly, if is empty, return -1, else return deque of back. Then again, if it is empty, oh, here I'll just return if size equal to 0, and here if return, oh, if size is equal to k. Now let's give it a run. I'm just wishing that this approach should work of 1 and k. Some silly mistake. Minus equal to k. Oh, equal to k. Oh, obviously wrong answer. Oh, I guess I need to go. Not much of an issue. It's this operation is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Get rare. Method get rare. That's anything wrong. Return deque of back. Okay, I understood. If return if back is equal to 1, then I'll have to return the last value. Return deque of k, otherwise deque of back. Now let's give it a run again. Still wrong answer. Okay, I'll figure it out. Oh, okay, so if my back is equal to 1, then I have to return deque of kth element, otherwise I'll have to return deque of back -1th element. I hope that this should run without any errors. Yeah, and it gets accepted. Now let's submit it. And works perfectly fine as well. Okay, so this was it for today. Thank you for watching.